The second part, elongation, starts with codon recognition. The tRNA with an anticodon complementary to the second codon of mRNA enters the open A site of large unit, and the fidelity function determines whether the connection is correct. The large subunit then catalyzes two reactions. It breaks the bond between tRNA and amino acid at P site and catalyzes formation of peptide bond between that amino acid and one attached to tRNA at the A site. When a large subunit connects amino acids, it is said to have peptidyltransferase activity, an enzymatic ribosomal function carried about by our RNA. The next step in elongation is called peptide bond formation, wherein a new amino acid is linked to methionine by peptidyltransferase activity. After the first tRNA releases its methionine, this free tRNA is moved to the E site and then in turn released from the ribosome. The ribosome shifts by one codon so that the growing polypeptide chain and the second tRNA, now bearing a dipeptide, moves to the P site. Note that the ribosome moves along the mRNA in a 5' to 3' direction. The peptide creation steps are assisted by elongation factors, primary EEF1 and EEF2, which aid amino acid linkages at the speed of 2 amino acids per second. EEF2 also promotes the GTP-dependent translocation of the ribosome. Bound GTP stabilizes the active conformation of a GTP-binding protein, and in translation, EF2 and EFG are the primary GTP-binding proteins that allow the ribosome to conform correctly. Translocation of the ribosome relative to the mRNA involves EFG, whose binding in the vicinity of the A site causes a ratchet-like motion of the small subunit against the large subunit.